Somewhere in China right now, factories are taking apart one of the oldest plants on the planet, fiber by fiber, and reassembling it into something that beats the timber humans have relied on for 10,000 years. This plant reaches full maturity in 3 to 5 years, not 3 to 5 decades. It's being shaped into flooring, structural beams, underground pipelines, wind turbine blades, and engineers have even tested it for high-speed rail carriages. Read that again. A country looked at the tree, arguably civilization's oldest building technology, and decided a humble grass could do the job better. And the story behind that decision starts with a puzzle nobody managed to crack for 2,000 years. Here's China's problem laid out simply. It builds more than any other nation on Earth, yet it doesn't have anywhere close to enough forest to keep up. Researchers writing in academic journals describe it as a widening gap between how much wood the country needs and how much it can supply. A single tree worth using for quality timber takes decades to grow, and China's construction sector was never going to wait that long. For years, that left the country with two options: keep importing huge volumes of timber from forests that are already shrinking worldwide, or find an entirely different material. And it turned out the answer had been growing on Chinese hillsides all along. Bamboo now covers 7.56 million hectares of China, made up of 837 different species, and together they produce over 150 million tons of raw material every year. That output is concentrated in 20 provinces, with Fujian, Jiangxi, and Hunan alone responsible for roughly 90% of the country's total supply. Technically, bamboo isn't a tree at all. It's a grass, and it behaves exactly like one. Certain species shoot upward faster than almost any other plant on Earth, reaching harvest-ready size in just 3 to 5 years. And here's the detail that makes foresters genuinely excited. Once you cut it down, it grows right back from the same root system. No replanting, no seedlings, no multi-year reforestation effort. It's essentially a renewable resource that keeps renewing itself on autopilot. But there was a catch, and it's the reason bamboo spent centuries relegated to minor roles: scaffolding, baskets, chopsticks, fishing rods, instead of holding up actual buildings. Raw bamboo is frustratingly inconsistent. It's a hollow stalk whose diameter, wall thickness, and strength shift from one pole to the next, sometimes even along the length of a single stalk. It splits easily. It buckles under weight. Its shape simply won't standardize, which means every single piece behaves like its own structural mystery. On top of that, it's prone to mold in humid conditions. One longtime bamboo craftsworker from Jiangxi recalled that the woven baskets and chairs from her childhood would go moldy almost as soon as the rainy season arrived. And that's a fundamental problem for engineering, because an engineer's whole job depends on knowing exactly how a material will behave under stress. Raw bamboo's defining trait was its refusal to behave predictably at all. So Chinese researchers made a decision that would eventually reshape the entire industry. Instead of trying to use bamboo the way nature grew it, they would break it down completely and rebuild it from scratch. The result is a product known as bamboo scremmer, and China is where the technology was first developed. The process itself sounds almost brutal. Bamboo stalks are crushed, then rolled and flattened into loose bundles of connected fibers, a stage the industry calls fiberization. Those fiber bundles are then soaked in resin until every strand is fully saturated. Next, they're stacked with careful attention to alignment, packed into a mold, and pressed under intense heat and pressure until they fuse into one solid, dense block. Gone is the hollow center. Gone are the natural joints. Gone is the unpredictability that made raw bamboo so hard to work with. What emerges from that process barely resembles bamboo anymore. It looks like a dense, dark hardwood, heavy, uniform, and consistent from one piece to the next. Every weakness bamboo once carried has essentially been engineered out of existence, leaving behind its single greatest strength multiplied many times over. Long, remarkably tough fibers packed together at densities approaching 1 gram per cubic centimeter, all running in the same direction, like a team of rowers who have finally synced their strokes. And the refinement goes deeper than you'd expect. Scientists discovered that even the number of times the bamboo gets crushed changes the outcome. Running the material through more fiberization passes lets the strips soak up more resin, which increases strength while cutting down on water absorption. With researchers pinpointing an ideal range of 1 to 2 passes and a finished panel density between 0.9 and 1 gram per cubic centimeter. Somewhere in a Chinese laboratory, there are peer-reviewed papers dedicated entirely to figuring out the optimal way to crush grass. That's the level of precision this industry now operates at. And once scientists finally had a version of bamboo that behaved consistently and predictably, there was really only one question left to answer, one that engineers had effectively been asking for centuries. How strong is this material, really, compared to the forests it's meant to replace? The numbers, it turns out, are where this story really earns its weight. Laminated bamboo, a close relative of scrimmer made from strips that are split, planed, and glued together, has been measured at roughly 3 times the structural strength of ordinary timber. It's serious enough that it now has its own formal classification under ASTM international standards, and engineered bamboo has already found its way into real-world use. Wall panels, vehicle flatbeds, concrete formwork, lightweight construction, and even temporary shelters built after the 2004 tsunami. Bamboo scrimmer, meanwhile, dominates the categories that matter most to builders. Systematic research reviews found it outperforms other engineered bamboo products across compressive strength, tensile strength, and bending strength. In laboratory conditions, its flexural strength, essentially how much bending it can withstand before breaking, has been recorded as high as 143 megapascals. To put that in perspective, that figure rivals premium structural hardwoods, the kind that take half a century to grow, coming instead from a plant that regrows in the time it takes someone to finish a college degree. Then there's the comparison everyone's really waiting for. How does bamboo stack up against steel? Natural bamboo's tensile strength ranges from about 115 to 370 megapascals, which actually overlaps significantly with mild steel's range of roughly 250 to 415. But tensile strength alone doesn't tell the full story, because bamboo is dramatically lighter than steel. Once you factor in weight, bamboo's strength-to-weight ratio comes out roughly 6 times higher than steel's. 6 times. That astonishing figure is exactly why researchers at the City University of Hong Kong made headlines when they unveiled an engineered version they nicknamed Super Bamboo, a material processed so that, relative to its weight, it performs on par with steel, explicitly framed as a substitute for wood and a step forward for sustainable building. When materials scientists start attaching the word super to a plant, the underlying data must be genuinely striking. That said, it's worth pumping the brakes a little here, because this is exactly the point where online enthusiasm tends to run away from reality. Bamboo isn't going to replace the steel framework holding up a skyscraper. For compact, high-load structural cores, steel's raw strength still wins that contest. But replacing skyscraper steel was never actually the goal. The real target has always been wood. Every floorboard, beam, wall panel, sheet of formwork, railing, deck, and door frame that used to require felling a 50-year-old tree. That's the market engineered bamboo is genuinely built to take over, and in category after category, it isn't just competitive with wood, it wins outright. There's also a safety advantage buried in the material science that deserves attention, and it might be the most compelling detail in this whole story. When bamboo scrimmer is compressed against the grain of its fibers, it shows high ductility, meaning it bends and deforms visibly and noisily rather than snapping without warning. Researchers specifically noted that this added ductility could give people more advance notice before a structural failure than timber typically provides, since wood tends to break suddenly and brittle. In simpler terms, the grass complains loudly before it actually gives out. In structural engineering, a material that warns you before it fails is worth more than its price tag suggests. The gap between a beam that creaks and one that stays silent is often the exact same gap between an evacuation and a catastrophe. So the science checks out. The lab data backs it up. But a dense block of engineered bamboo sitting on a workbench doesn't reshape an entire industry on its own. What actually shifts an industry is someone figuring out how to make that material do something wood was never physically capable of doing in the first place. And in 2006, one engineer in Zhejiang province did precisely that. His name is Ya Ling, and his original idea sounds almost like a challenge thrown out at the end of a long dinner conversation. What if bamboo could be wound into a pipe? Underneath that question was a genuine scientific insight. Compared to wood of similar moisture content and dimensions, bamboo is remarkably more flexible. It can bend into large, sweeping curves without snapping. That flexibility comes from a structural gift built in by evolution itself. Bamboo is what's known as a naturally functionally graded material, meaning the size and density of its fiber bundles shift gradually from the inner wall of the stalk to the outer surface, giving it a bending capability wood simply doesn't have. Wood breaks where bamboo curves. In a sense, nature had already engineered this plant for winding. It just took a few thousand years for someone to notice. In 2006, Ya Ling pioneered what's now known as wound bamboo composite pipeline technology. The process feeds continuous slivers of bamboo, soaked in resin, through a mechanical arch-shaped device that winds them layer over layer into large diameter pipes. Nearly a decade of refinement later, the technology reached full industrial rollout in September 2016, with 3 production facilities up and running. Along the way, Ya Ling accumulated no fewer than 66 patents, and he now serves as both board chairman of his company, Jiangji Xinlin, and director of a national engineering research center for bamboo winding composites operating under China's Forestry Administration. This is someone who looked at the most common plant growing across southern China and saw billions of dollars worth of underground infrastructure hiding in plain sight. His timing turned out to be almost perfectly calculated. He was pushing the technology toward maturity right as China's oil and gas pipeline network was projected to expand from 150,000 kilometers to roughly 240,000. And the performance data backs up the ambition. Published testing on wound bamboo composite pipe found its ring stiffness, its resistance to being crushed from the outside, a critical property for anything buried underground, comparable to fiberglass reinforced plastic pipe, while coming in 46 to 55% lighter. That means roughly half the weight for the same structural performance. And when it does eventually fail, it fails gracefully. The bamboo pipe deforms by nearly 30% of its radius before actually fracturing, about 9 times more deformation than fiberglass typically shows before its sudden, brittle break. Once again, this grass-based material gives you warning before it lets go. Politeness under pressure seems to be baked into bamboo's fundamental character. The Chinese government took notice. Bamboo winding composite pipe was officially designated a national key low-carbon technology, and both the Forestry Administration and the Housing Ministry assessed it as internationally advanced. The Forestry Administration even projected a future rollout of 500 large-scale production facilities for wound bamboo materials, targeting a combined output value beyond 200 billion yuan. But the endorsement that really cemented its legitimacy came from heavy industry itself. In January 2021, China Railway Construction Corporation, one of the largest construction firms on Earth, opened its own bamboo winding pipe production base in Chongqing's Banan district, with an annual capacity around 9,000 tons and an output value near 200 million yuan. When a company that builds railway infrastructure across continents starts manufacturing pipe out of grass, that technology has unmistakably graduated from the research lab into mainstream industry, and the range of applications keeps expanding. Published research points to uses in farmland irrigation systems, urban underground pipelines, modular construction, and even potential use in high-speed rail carriages. The International Bamboo and Rattan Organization has confirmed that the winding technology has been trialed for everything from storm drainage pipes to actual high-speed rail compartments. Sit with that for a second. The country running the largest high-speed rail network on the planet is actively researching whether future train bodies could be wound out of bamboo. Somewhere right now, a legitimately funded engineering program is testing a 350 km/h train built from grass. But no national technology proves itself through pilot projects and patents alone. It needs a place where the entire economic model gets tested from top to bottom. For China's bamboo economy, that proving ground is a single county that most of the world has never heard of. Roughly 2 hours southwest of Shanghai sits Anji County in Zhejiang Province, home to more than 1 million mu of bamboo forest, around 66,000 hectares of green stalks stretching in every direction you look. Anji has been officially designated China's bamboo county, and it has embraced that identity with something close to civic devotion. There's also historical weight attached to this place. It was here, 2 decades ago, that Xi Jinping, then serving as a provincial party secretary, first declared that lucid waters and lush mountains are invaluable assets, a phrase that would go on to become the founding slogan of China's entire green development philosophy. So Anji isn't just an economic pilot project, it's treated as a genuine national showcase. And the economic figures out of the county are striking. Around 1,000 enterprises in Anji operate within the bamboo industry, and in 2023 alone, that local industry generated approximately 18 billion yuan, close to 2.5 billion US dollars, from grass grown on county hillsides. One company, Jiang Fengyuan, reported 130 million yuan in annual revenue, selling products across Europe, Japan, the United States, and Southeast Asia, with exports accounting for roughly 80% of its business. These products aren't stocking local souvenir stands. They're filling international shipping containers. Walk through Anji's Bamboo Exhibition Center, and the sheer breadth of products on display starts to feel almost surreal. There's bamboo cutlery, straws, and packaging boxes, bedding and clothing spun from bamboo fiber, bamboo toothbrushes, combs, and even bamboo-based toothpaste. Since 2022, local government cafeterias have swapped plastic food trays for bamboo ones, and bamboo tableware now shows up in more than 300 restaurants and hotels across the county. Official figures put the rollout at over 6,000 tableware sets deployed across nearly 300 hotels, which has cumulatively eliminated more than 3.5 million disposable plastic items from circulation. Even the leftover waste got recruited into the supply chain. Fallen bamboo shoot shells that used to just decompose on the forest floor are now collected and pressed into food trays and containers used for delivery meals and camping supplies. Somewhere in Anji, a discarded husk that used to be nothing more than compost now has a second career serving takeout orders, arguably a more dramatic career change than most of us will ever experience. The material's old weaknesses have been engineered away here too. Through high-temperature carbonization, bamboo is transformed into charcoal-treated products, resulting in mold-resistant chairs and chopsticks that hold up against the humid Zhejiang summers that used to ruin traditional bamboo goods within a season or two. Meanwhile, at the Anji National Bamboo Industry High-Tech Park, one company spent more than a year developing flame-retardant formulations and testing injection molding techniques to create an entirely new type of bamboo board. The same material that once couldn't survive a rainy season is now being engineered to meet fire safety codes. Anji matters because it functions as the blueprint. When Beijing rolled out its National Development Plan in 2023, Anji was named among the very first demonstration bases. The working model the rest of the country has effectively been told to replicate. And that brings the story to the part that turns this from a charming regional success story into a genuine global industrial strategy, a plan aiming for 1 trillion yuan. Here's what most coverage of engineered bamboo tends to overlook. This isn't a scattering of small startups and artisan workshops. This is coordinated national industrial policy carried out with the full machinery of the Chinese state, and the paper trail confirms it clearly. The timeline is methodical and deliberate. In 2022, China partnered with the International Bamboo and Rattan Organization to launch what's called the Bamboo as a substitute for plastic initiative. By November 2023, the two organizations released a global action plan running through 2030, laying out 6 overarching goals and 23 specific actions designed to shift not just China, but the entire world, from plastic toward bamboo. Later that same year, China's National Development and Reform Commission issued a 3-year action plan to accelerate the sector, complete with an official catalog defining 3 major and 17 minor categories of bamboo-based plastic alternatives, plans for 5 to 10 demonstration bases, and firm targets, raising the added value of key products by more than 20% compared to 2022 and lifting the utilization rate of harvested bamboo by 20 percentage points. Individual provinces followed with their own ambitions. Jiangxi is aiming for a 100 billion yuan bamboo industry of its own. Fujian has plans for 5,000 kilometers of bamboo mountain roads. By early 2024, more than 20 industrial bases dedicated to bamboo-based plastic alternatives were already under construction or in the planning stages across 17 provinces. Then came the part that sounds unglamorous but matters more than almost anything else in this story: standardization. No builder anywhere is going to specify a material that doesn't come with a reliable rulebook behind it. A standardization working group was formed in September 2023, and by September 2024, China's Forestry Administration had released a dedicated standard system spanning 9 categories. Everything from engineering and building materials to agricultural equipment, medical supplies, appliance housings, and everyday household goods, covering 140 standards that were released, revised, or still in development. By January 2026, the administration announced that the industrial system had been preliminarily established, backed by more than 900 million yuan in direct government funding, with the number of distinct bamboo varieties surpassing 15,000. There are entire established industries with shorter product catalogs than that. Now consider the growth curve itself, because it's the kind of trajectory that makes economists sit up. In 2010, China's bamboo industry was valued at 82 billion yuan. By 2022, that figure had climbed to 415 billion. By 2023, it reached roughly 541 billion yuan, or about 75 billion US dollars, earning bamboo the international nickname green gold. That represents an average annual growth rate north of 30%, sustained for more than a decade, spread across more than 10,000 processing enterprises, with China's bamboo trade volume now ranking first in the world. According to state media, the industry currently employs more than 29 million people, over 19 million of them farmers, which means this materials revolution is simultaneously functioning as a rural income policy, channeling money directly into village economies. The official target sitting at the end of this road is total industry output exceeding 1 trillion yuan by 2035. And the product list keeps stretching further than anyone might expect. Bamboo keyboards and computer mice have been showcased at trade fairs in Beijing. There are bamboo bicycles, bamboo phone cases, and even bamboo wind turbine blades in development. Researchers found that bamboo epoxy laminates match or exceed conventional wood epoxy laminates currently used in blade manufacturing, performing comparably across tensile strength, compressive strength, elastic modulus, and shear strength. The same plant that once mostly made fishing poles is now being seriously evaluated for use in machines that generate a nation's electricity. Some officials have even claimed bamboo could realistically substitute for plastic across at least 80% of application fields. But this is the point in the story where it's worth pausing to be completely honest, because real cracks exist in this narrative, and they're worth examining just as carefully as the successes. Start with the economics. Right now, bamboo products are more expensive than the plastic items they're designed to replace. Industry insiders are candid about the reason. Even though fossil fuel-based plastic generates far more greenhouse gas emissions during production, it remains cheaper because harvesting and processing bamboo involves higher labor and transportation costs. Steep hillsides don't harvest themselves, and a plastic pellet never required a mountain road to reach a factory. One industry expert summarized it bluntly. Replacing wood with bamboo is already common practice, but fully substituting for plastic is far more difficult, and real-world large-scale applications remain limited so far. Second, and this comes directly from the government's own action plan, which is unusually candid about its shortcomings. The industry is still relatively small in scale, productivity remains low, costs are high, and technology and equipment continue to lag behind where they need to be. That's Beijing grading its own progress, and it didn't hand itself a top mark. Domestic consumer demand is still catching up as well. Bamboo products are gaining real traction faster in European and international markets than they are within China itself, where public habits are shifting more slowly and continued incentives are still needed to move the needle. Third, there's a structural ceiling to reckon with. Engineered bamboo still lacks universally agreed building standards from regulatory authorities for high load-bearing applications. Laminated bamboo has earned formal ASTM definitions, but you still can't walk into most building departments anywhere in the world and get a bamboo high-rise approved the way you could with steel or concrete. Until building codes catch up, there's a hard limit on how far the material's structural ambitions can currently go. Fourth, consistency. The very demon the industry was originally built to exercise hasn't been fully defeated. Research reviews found that bamboo scrimmer products still vary considerably between manufacturers, depending on differences in processing methods, treatments, and internal mat structure. One study measured tensile strength around 34 megapascals using basic manual fiberization, while another recorded 111 megapascals using proper industrial processing, a threefold difference within the same general material category. In other words, the finished block is only as reliable as the factory that pressed it. And fifth, there's a quiet irony worth acknowledging. Most bamboo scrimmer is bonded using phenolic resin, which is a petroleum-based adhesive. The material marketed as a green alternative is, in practice, held together by a small piece of the fossil fuel world it's meant to replace. Bio-based adhesives are an active area of ongoing research, but for now, every bamboo beam still contains a small handshake with the old industrial order. None of this undermines the broader story. It simply suggests the revolution is maybe a third of the way through its arc, which arguably makes it more compelling to watch unfold, not less. And to really understand where this is all heading, it helps to appreciate just how long this particular plant has actually been waiting for a moment like this. Here's the perspective that reframes the entire story. China has been working with bamboo for roughly 7,000 years. Long before paper existed, Chinese civilization recorded its history on bamboo slips. Thin strips bound together with cord, carrying philosophy, law, and poetry across successive dynasties. Bamboo became arrowheads and baskets, writing pens and scrolls, footwear, food, and even entire buildings. Historical records describe bamboo architecture flourishing in the Lingnan region 2,000 years ago, including a temple from the Han Dynasty built from the material. In Jiangsu, in Hubei province, bamboo weaving is now formally recognized as intangible cultural heritage, with local farmers earning an extra 20,000 yuan a year from the craft alone. When a civilization's earliest written memory was literally stored on a plant, that plant was never just some minor material curiosity. It was a founding partner in that civilization's development. Then the 20th century arrived, and that founding partner got sidelined. Concrete, steel, and plastic swept across the world, and bamboo was demoted to scaffolding poles and souvenir shop shelves. Quaint, traditional, largely obsolete. For the better part of 100 years, arguably the fastest-growing structural material on the planet was treated as little more than a museum relic. What ultimately changed wasn't the plant itself. It was the surrounding math. Climate targets transformed bamboo's core advantages: explosive growth speed, the ability to regrow without replanting, exceptional carbon capture, and full biodegradability. From charming trivia into genuine strategic assets. China has pledged to reach carbon neutrality by 2060, and officials at the International Bamboo and Rattan Organization have said the government is placing serious hope in bamboo as part of that path. Other bamboo-rich nations across the global south are now studying China's approach closely, because whichever country manages to industrialize its bamboo resources first stands to inherit a meaningful share of this expanding global market. So the 7,000-year-old partner has effectively been called back into the game, except this time, it's arriving equipped with resin chemistry, hydraulic presses, industrial winding machines, 66 patents from a single inventor, and 140 formal industry standards backing it up. Step back now and take in the full arc of this story at once. A grass that outgrows every tree on the planet gets crushed and reborn as scrimmer, a material that beats timber across category after category of strength testing. That same plant gets wound into pipelines that match fiberglass's performance at roughly half the weight, now rolling off China Railway Construction Corporation's production lines by the thousands of tons. A single county has built an 18 billion yuan economy almost entirely around it. A national master plan is aiming for 1 trillion yuan in industry value by 2035, and active trials are already underway to determine whether the high-speed trains of the future might one day be wrapped in the very same material. While much of the rest of the world continues debating how to plant more trees, China spent 7,000 years learning exactly what its fastest-growing plant could do, and then spent the last 20 years teaching that same plant an entirely new set of tricks. Wood held a 10,000-year monopoly as humanity's primary structural partner drawn from the natural world. That monopoly has just come to an end, and it was a grass that ended it.